Hello everyone. So we are looking at chapter 6, which is the normal distribution. Now we are already familiar with the normal distribution, at least this much, that the shape of the normal distribution is a bell curve. And remember, we were able to use the empirical rule for the bell curve. So these are for normal curve or normal distribution. We start with an example, something similar which we have seen before, and then introducing something new. So example 1, I'm looking at that suppose that ACT scores taken at a local high school have a mean of 21 and a standard deviation of 1.5. So it says use the empirical rule to determine what scores are needed to be in the top 16%. So if you recall the percentages, so if we are one standard deviation away from the mean or between one standard deviation of the mean, so this is mu minus sigma, mu plus sigma. So we said 68% of the data is in here. So the what is here, what we have left here, if you remember what we do, we subtract 68% from the 100%, because the bell curve has 100% area under there, so 100 minus 68, 100% minus 68%, which gives us 32%. But this 32% is the area here on the left side of, and the right side both. So we want the area to just to the right side. So this is 32 is the combination of these two areas. But because of symmetry, the areas are same. So it means I take 32% and divide by 16%. Okay? So which means divide by 2, which gives us 16%. So this area is 16%. We wanted to see this basically we wanted to find this number, so that on the right of it is 16% area. So you know what it does, it is giving us, we say area, but it is the same thing kind of as the percentile. So what is the number? Well, we get this 16% when we have the number over here, or the value here is equal to mu plus sigma. So mu is 21 and sigma is 1.5. So this means the value will be 22.5. Now suppose, let's look at B part. Suppose someone earned a score of 23 on the ACT. What percentile are they in? So we try to see that can we attain 23 from doing the addition of 1.5, multiples of 1.5. So when I add 1.5 to 22, we saw we get 22.5. Then 22.5, I add 1.5, I get, I think it's like 24. Okay, so which means I didn't get 23. So where is 23? So 23 lies somewhere between the second mu plus 2, mu plus 1 and mu plus 2. Sorry, so mu plus 1 here, mu plus 2 here. Then this somewhere here the value lies. Okay, this value 23 lies somewhere here in between. So now because it is in between those, so we cannot use empirical rule for this. So what do we do then? We use something called a normal, standard normal distribution, or standard normal distribution tables. So this is basically what we say is the limitation of the empirical rule, that it only gives us the value which are exactly I mean, it only gives us the values, namely, or we can use it for only values which are plus minus 1 standard deviation, plus minus 1 or plus minus 2 or plus minus 3 standard deviation away from the means. So if our x values are such that they are one of these standard deviations away from the mean, then we can easily tell by using the empirical rule. But what about the other ones? For them, we use the standard normal distribution or standard normal distribution tables. So what is a normal distribution? We say a normal distribution is a continuous probability distribution. So you have to remember this, because a question like this can come up in the exam. What is a normal distribution? And or you can have a fill in blank type of question. So normal distribution is a continuous. So remember, it's a one thing, continuous. Second thing, it's a probability distribution. Okay, that is completely defined by the mean and by its mean and its standard deviation. So mean, mu, and standard deviation, sigma, and this is kind of the symbol that we use for the normal distribution. So and the uppercase n, which represents the normal distribution, and mu and sigma. So if you see written like n 2 comma 1, then it means the mean is, this is we are talking about a normal distribution in which the mean is 2 and standard deviation is 1. If you have in the same way, if you see something like n, and then you have like 0 1, that is a standard deviation with mean 0 and normal distribution with mean 0 and standard deviation equal to 1. Now the graphical representation of a normal distribution is symmetric bell-shaped curve. Again, a question, what is the shape of a normal distribution? So this is what the answer would be. The normal distribution is a symmetric bell-shaped curve centered above the mean of the distribution. Okay? So these words, each of them is important. So here is a picture. So this one is a normal distribution because it's a bell-shaped curve and it is symmetric. And the mean will be here. Actually, mean, median, mode, all will be here. They will be equal. Now, compared to this picture on the right, this has nice peaks, bell-shaped curves like joined together, but this is not a normal distribution because they are. It's not like a single bell-shaped curve. Okay, or note that the curve of a normal distribution will approach the x-axis on both ends, but will never touch or cross it. Okay, so this is something I mentioned the other day in the class. So you should not make it go touch. Now, and some people draw it like this. It is actually not correct because you are showing that it is touching. So what happens is that where we feel like they are touching, if actually we zoom in, so they are far apart, like this. Okay, so if you take this like this and you say, oh, here it looks like it's going to touch. If you zoom in again, it will be far apart. So remember that, don't make it touch or cross the x-axis. So here this is good because this is staying above the x-axis, and then but this is not good because it has been crossed the x-axis. The properties of a normal distribution, again these were underlined words are something you have to remember. A normal distribution is a bell-shaped curve which is symmetric about its mean. A normal distribution is completely defined by its mean mu and its standard deviation sigma, and it is referred to as n mu sigma. The total area under a normal curve equals 1 or 100%. Okay, so if we talk in percentages, then we have 100% area is under the bell curve, and if we talk about numbers area, then we can say the area under this curve is one unit, whatever unit the question, whatever the question is using. Okay, whatever unit the question is using. So that will be the units for that area. Now, the normal distribution, the x-axis is a horizontal asymptote for a normal distribution curve. So this is also important words. Could be a fill-in-blank question, or could be what is the significance of the x-axis in the normal curve. The normal distribution is actually a pretty powerful distribution that is used in statistics, and it has its own language, special language. Okay, and what is that special language? In the language of standard deviation. Like it talks in only in standard deviation. So if your value is like a some multiple of standard deviation of the quantity, then only you can use the then only this can help you, the normal distribution can. So if you recall, that's how we were doing it in empirical rules. So I show you something here. When we are one standard deviation away, so if you recall, the formula for finding the z-score of a value was x minus mu. Z is equal to x minus mu over sigma. So if our x value is mu plus sigma, okay, mu plus sigma. So then if you plug in for x, you get z is equal to mu plus sigma. So what am I doing here? Let me show you. So what I did here, if you note, I have the same formula as I have here, but I only replace the x value by mu plus sigma. So you can see when you remove the brackets here, the mu and the mu will cancel out, and you will be left with sigma over sigma, which is 1. So one standard deviation away from the mean is 1. It's a z value is 1. When we are two standard deviations away from the mean on the right side, then the z value will be 2. Now what about the left side? So for example, if you have your x's, take a new color. So if our x is, let's say, mu minus 2 sigma. So now we can plug in the formula, this value for x. So we get x is equal to, so at the bottom we have sigma, and we have mu over here, and then we are using, in place of x, we will be using mu minus 3 sigma. So plus this value, plus mu, sorry, minus mu. Okay, minus mu. So mu and mu will cancel. We will be left with 3 sigma over sigma, so which is equal to -3. So we have a -3 sigma after in the top, so we get -3 here. So this is what happens. When we convert to z-score, these values over here they change to 0, 1, -1, and so on. So which is telling us that this normal distribution with mean 0, so n 0, 1 and 0, 1, mean is mu, mean mu is 0, and the standard deviation is 1. So that is a special kind of a normal distribution curve or normal distribution. We call it a standard normal distribution. So we'll come to the standard normal distribution in a few minutes. Let's look at what is happening here. So recall that in example 1, part A, in order to use the empirical rule, we had to convert the ACT scores to standard deviations. And for the percentile, we refer to the related area under the curve, under the bell curve. Remember, I just showed you that we were looking at this area on the right here, under the bell curve. And this percentage of when we are representing the area in terms of percentage, that is basically telling us about the top 16 percentile. So it means that to be in the top 16 percentile, the person should have a, maybe I should write like a sentence, answer in a sentence: to be in the top 16%, one must have at least a score of 22.5 on ACT. So it means this person who had a score of 23, they are in that top 16%. So now, in order to find what the percentile of the number 23, we must convert it into a z-score, because z-score, remember, it gives you the standard number of standard deviations. The quantity or the value is away from the mean. Could be to the right, could be to the left. So what is the formula for z-score, as I showed up here? So this is, again, I wrote the formula here, and everybody should know mu is the mean, population mean, sigma is the population standard deviation, z is the standard score, or also called z-score, also called z-value, and x is the data value. So let us look at what the z-score we get for the ACT score of 23 in part B. So we have the mu is equal to 21, sigma is 1.5, and the x value is now 23 in part B, remember. So we plug everything in the formula and we end up getting positive 1.3333 and so on. Now, when you are calculating z-score, you have to be careful. You must stop after 2 decimals. And when you stop, you have to follow the rule of rounding. Okay, I hope everyone knows the rule of rounding. So, rule of rounding: if, in this case, if the third decimal place, if third decimal place, if in the third decimal place, that's how I should say it. If in the third decimal place, the number is 5 or higher. So higher means you can have 5, 6, 7, 8, or 9. We truncate and add. We stop after 2 decimal places, or we truncate the value after 2 decimal places, but increase the second place, or we can say add 1 to the, but add 1 to the second decimal place. So if the number is in the third decimal place is less than 5, means it is 0, 1, 2, 3, 4, then we just stop after the second decimal place. For example, if you have 1.7369 something. So if you have to stop after 2 decimal places, so this is my second decimal place, I can put a line like this after the. So then I look at the number on the right of this line, the first digit to the right. If it is 5 or greater than 5, I will truncate all these, but I will have to add 1 to the second decimal place. So it will be rounded as 1.94. And if the number was 1.932, for example, and then whatever 190, so then if I have to truncate after 2 decimal places, I draw a line here. I see the number on the right is less than 5, so we say that this is value is equal to just 1.93. Okay, so here, so this is something important, that you always find the z-score rounded to 2 decimal places. And the reason you will note in the next section, when we calculate from the table from which we calculate, the related areas, the table has only 2 decimal places for the value of z. Okay, so now let us try to do some examples here where we are going to find the z-scores for each of the given data value or given value, and then we also want to show by making the bell curve where does that z value lives on the x-axis. Okay? So it says that given a normal distribution, so we have the normal distribution, and then we have a mean of 48 and a standard deviation of 5. So we will be now calculating the z-scores for these. Okay, let's see. So x is 60. We have mu and we have the standard deviation. Now this should actually be sigma. Okay, so mu, so z will be equal to x minus mu. So again, this is also important to remember. So even if you feel like you have memorized the formula, please check with your formula sheet, because sometimes students reverse this thing. So can you see, if you reverse this, then you will get a negative z value instead of a positive, and if your actual z-value was supposed to be negative and you reversed it, you will get a positive z-value instead of a negative. So which can alter the final solution. So x is 60, mu is 48, and standard deviation sigma is 5. And now I take out my calculator and we calculate this value, which comes out to be, maybe you guys can do it, try it faster than me. So 60 minus 48 divided by 5. So I got 2.4. Now 2.4, as I said earlier, we should write it in 2 decimal places so we can put a 0 here. So this is how you will calculate the z-score. Now notice here, when you enter in the calculator, you can, if your calculator allows, it's a graphing or scientific calculator, then you can actually use parentheses around these values and slash divide by 5 in one go. In one go you can find it. Otherwise, in other simple, very basic calculators, you will have to do 60 to 48, which is what? 10 minus 8 is 2, 5 minus 4 is 12. Okay, so now we take, don't please do this. This will be wrong. 2.4, sorry. That's what you get. So this is correct. But when you have this written here, we are basically saying this is going to be so we had a 12 over 5. So this, because we don't have a 5 under here, so where is this 5 coming from? So instead, I would recommend that you write it like this. Instead of dividing the 5 by 5 over there, first find the difference of these two numbers, which is 12, then go to the next line, 12 divided by 5, which is 2.4. So that is your z value. So z is equal to 2.40. Same thing with the next one. Now, oh, by the way, so we have to now sketch the graph, show where it lives. Okay, so maybe I'll take this away from here. So I think this work is enough that I showed over there. That is the z value. Now how will you show it on the graph? So make a normal curve like this and 0. So this is 2.4. So you can see it is somewhere between the second and the third standard deviations on the right, in between those. So you can roughly say somewhere here, 2.4. Z is equal to 2. And if you want to look at it in terms of the mean, the given mean is 48 and we are talking about 60. So 60 will be to the right of 48. So somewhere here will be 60. So what we do when we have z-score, we similar kind of shapes, both are bell curves, but the mean here is different than the mean there. So which allows that the width of the curve or the height of the curve could be, it won't be the same as the normal curve. So next example, we have z is equal to 45. Sorry, x is equal to 45. So z will be equal to 45 minus 48. So now you see z is 45, x is 45 means the value is less than the mean. So it will be towards the left. So z is equal to 45 minus 48 over 5. Now 45 minus 48 is negative 3. So negative 3 divided by 5 is negative 0.60. So how will you show it on the number? So this is the 0, and so somewhere here will be negative 0.6. Okay, I hope you understand what I am doing here. C part, so it's x is equal to 36. So again, z is equal to 36 minus 48. So you can see this is going to be further away to the negative side than the previous one, because it's more the difference between the x value and the mean is bigger. So this value will give us, where did my calculator go? So if we do it orally, so 8 minus 6 is 2, and then 4 minus 3 is 1. So we are getting negative 12 over 5. So what is that? 2 point, so it will be negative 2.4. Okay, so that is what we get. So, and you can, so notice here that when we had the value 60, we got 2.4 for the z-score, and now for value 36 we are getting again negative 2.4. So, and because of the symmetry, let us try to see if the distance between the mean and the 60 and the mean and 36 should be same. So 60 minus 48 is 12, and 48 minus 36 is also 12. So that's what I expected. So anyhow, so this is how you will find the z-scores, and this is how you will be locating your z-scores on the normal curve, because it's important that you know how to draw this curve and how to put the z-scores in their proper place. So this is 0, so z-square is going to be somewhere over here, this negative 2.4. Okay, so this is section 1. So in section 1 you basically are converting data value into a z-score, and then indicating where it lives on the normal distribution, standard normal distribution. In the next video, talk about section 6.2.